All right, guys, so on page 4 of the packet, and I know some of you recall this or you kind of checked in with me, and so you've gotten a head start here. I'll try to catch up with you. We're using what's called the power rule. So here we are raising the whole monomial to a power. You'll see the exponent, there's an exponent on the outside of the parentheses, and there could be just one part inside. One, monomial could be very simple, or it could have lots of parts, right? So in this case, the one in the little rule is just x, and we multiply the exponents. So let me kind of show you an example of how that works, not just that that's the rule. Think about if I said x to the second raised to the 4th power. Well, something to the 4th power would mean that we would write what's inside 4 times. So if I wrote x to the second times x to the second times x to the second times x to the second, we could use product rule, and we would add all those 2's together, 2 plus 2 plus 2 plus, and we would get 8. So we could force it into being product rule, and what we would find is that we get 8. And then we should stop and think, is there an easier way to get to 8 besides doing 2 plus, oh, repeated addition is just multiplication. So we can just do 2 times 4. So when it is just one variable, very simply, we are just doing, this is just this, and we get x to the 10th. By the way, you don't need to write the 2.5. That's just me kind of showing what I'm doing a little bit there. If there's 2 variables, it's like that 4 on the outside is going to distribute to both of them. So then I'll be doing m to the 7th. The 7 gets times 4, and the 4 gets times 4. So that's kind of what's happening. I'm thinking this first part, and then I'm writing this. I'm thinking n 4 times 4, and I'm just writing n 16. So probably what I have here in the middle is not something you would actually write down. You would probably just think about the m's and then think about the n's and write it down. This is where it is very important that we remember that those fellows who don't have exponents have a 1, so that then to get this I'm doing c to the 1st times 3rd, so I have c to the 3rd. Then after I think about that, I'm doing d 2 times 3 to get d to the 6th. So it doesn't just stay plain old c, it's now 3rd power, because each one of them, each time there would be 1. So altogether it would be to the 3rd power. So those only had variables. Now we have some with coefficients. And once again, reminder, the big number and the tiny number are not going to behave the same way. And for something like this first one, we could write it out separately, and it would probably make a lot of sense to us, because we can think that this is the same as doing this, but it would not be convenient to rewrite it repeatedly if the numbers get bigger. Okay? So if the numbers get bigger, rewriting it is not convenient. We need to just know that we're raising 5 to the 2nd power. So basically I'm doing this, 5 to the 2nd power. I put this little thing because that's what you would type in the calculator. Now, 5 to the 2nd, most of us know is just 25. Simple enough. But if it's something you don't know, then using this button on the calculator, instead of going 2 times 2 times 2 times 2, oh crap, how many times did I put it in there? but maybe I'm the only person who has that moment. And then x, 7 times 2, 14th. So final answer, and what I wrote in the middle there is really just like thoughts that should be coming through your head or going into your calculator. I would not anticipate you would usually write that down. Sometimes when people are just learning, they write that down a couple times just to remind them what they're doing. So this means the same as doing 2 to the 5th. And if I do that, I get 32. And then I'm doing x to the 2 times 5. So x to the 10th. And then y is 1 times 5. So y to the 5th. And again, this is just like the what's happening in my head. But it doesn't really all happen at once. It's like the first thing happens, and then I write down 32. And then the second thing happens, and I write down x to the 10th, etc. Now, the next thing, negative numbers. And I think I mentioned this really early in this class, that negative numbers, so if you have negative coefficients, negative numbers, to even powers, second power, fourth power, sixth power, 10th power, anyway, they will give you positive answers. So negative 2 to the second is positive 4. If you are counting on your calculator to tell you, then you're going to need to put in your calculator this way to the second. Because if what I type in my calculator is this, the calculator thinks, oh, you want me to do 2 times 2 and then make it negative. Because exponents come before other operations, right? So that's why if you type this in the calculator, it tells you negative 4 for most calculators. If you want it to mean that there are 2 negative signs, negative 2 times negative 2, you need to put it inside parentheses. Personally, I just remember that if it's an even exponent, 2, 4, 6, 8, 0, anything that ends in 2, 4, 6, 8, or 0, I just know it's going to be positive. And if it's odd, it's going to be negative. So then I don't type the negative number in, but I keep that rule in mind. And then go back to 4 times 2 and 6 times 2. So once again, coefficients are going to behave differently than your exponents. All right. All right, so number 7, negative 4 to the 4th power. 4 is an even number, so I know I'm going to get a positive number. 4 to the 4th power, 256. Then C, 3 times 4. D, 4 times 4. Number 8, we have another negative coefficient. Is 3 an even power? Is 3 an even number?
No.
No. So this will stay negative. So 3 to the 3rd power is 27. That is going to be negative. And then 2 times 3 is 6. 1/2 to the 3rd power. Well, 1 times 1 times 1 would still be 1. And 2 to the 3rd power would be 8. If you type that in a calculator, you might have gotten 0.125 as a decimal instead. And then 3 times 3, 4 times 3, and 5 times 3. And then our mixed practice is really using power rule and then product rule. So if there's an exponent on the outside, we need to get rid of those exponents. If it's on the outside of parentheses, we're going to get rid of those exponents first using power rule, and then it's going to turn into a problem like the previous page where we're going to add the exponents from the two products because we're going to multiply it all together at the end. Your final answer should not have more than one x or more than one y, or a's or b's or whatever, insert variable. So here, x, 3 times 3 is 9, y, 3 times 3 is 9. That part becomes that. This second part just stays the same. You could rewrite it or just put it in your head or think about it up there. And then now, to put those together, now it's a multiplication. So it's product rule. Then add your exponents. So 9 plus 1 and 9 plus 2. So because exponents come before multiplication in order of operations, we need to get rid of the exponent that's on the outside of the parenthesis first, then do the multiplication, which is when we add the exponents. So sometimes it's the second part that needs simplified. Now that negative sign is like a -1. If a negative to an even power, it's going to become positive. So I don't have to write +1, but the negative sign is now gone. And then 2 times 4 is 8. And 1 times 4 is 4. And then that is going to get together with that a to the 3rd to make a to the 11th. B is just going to stay b to the 4th. But the negative sign is no longer there. Now, if that minus was outside the parentheses, that would be a different thing. Then it would look different. And especially if we didn't see that dot, then it could mean that we are subtracting instead. But it's inside, so we are not left to wonder. And then starting with 12, we have exponents on the outside of both of those monomials. So we've used power rule both times. -2 to the second power, +4. Then a, 1 times 2 is 2. B, 2 times 2 is 4. Now I'm going to go over here, get rid of his exponent that's on the outside. 3 to the second power, 9. A, 2 times 2 is 4. B, 1 times 2 is 2. Now we need to push that together. Like, actually, now this is basically like a problem you had on the other page. 9 times 4, 36. So multiply these two guys. Add those exponents. So A, 6, and B to the 6th. So if you think you're done, but you still have, there's no pluses, but you still had like 2 different A's written down, something is probably not right. So here I have 6 to the 3rd power, so I'm just dealing with this. That's 216. A, 2 times 3 is 6. B, 1 times 3 is 3. Then I need to deal with this guy. 1/3 to the second is 1/9. So 1/3 times 1/3 is 1/9. And then A2, B2, C2. And now I've run myself out of space, but now we're going to put those together. So 1/9. So we're going to do 216 divided by 9. I think that's 24. Yeah, I feel good about that. 24. And then A, add my exponent. 6 plus 2 is 8. B, 3 plus 2 is 5. And C, nothing plus 2 is still 2. So C is still part of it because they don't have to be like terms to multiply. Just add and subtract.
What if the 216, let's say, was a number that doesn't divide by 9?
If the 216 was a number that doesn't divide by 9, you could have a fraction as part of your answer, yeah. I would not, if it didn't divide evenly, I would not want to use a decimal because the decimal would be repeating since it's 9. And that takes us through, I believe, we got one more, yeah, we got one more line there, sorry. And then we've got our geometry ones. The geometry ones just force us to use the rules, but we got to be reminded about some geometry formulas that we probably haven't used in some time. So, neither of these have fractions, so that might seem better, but these two, now we're going to use power rule, product rule, and combine like terms. So as soon as I saw this in the middle and this in the middle, I knew, oh, we're going to even combine like terms on these problems. So if there's an exponent on the outside, I need to handle that first. So please do not try to put this and this together because we're not on we can't do addition yet. We can't do addition until the end. So 2 to the 3rd power, 8. 2 times 3 is 6. So now I've taken care of power rule. Power rule would come first, then product rule, which means I could do this next because there's no power rule over here. That becomes 3a for plus 2 is 6. Now that I've already gotten rid of all those parentheses and simplified, now I can add them together. 8 plus 3, 11. And on the addition step, we do not change the exponent. So very similar for 15. The first monomial, we will get rid of the power first. So 3 to the 4th power. What is 3 to the 4th power? 81. Good. And then x, 3 times 4. Y, 1 times 4. So we've gotten rid of the exponent on the outside. We don't need those parentheses anymore. And then over here, we've got to get rid of this exponent on the outside. So 7 to the 2nd power. The minus sign is on the outside, so it's not getting rid of the minus. 49. X to the 5 times 2 is 10. Y to the 1 times 2 is 2. And then next, I need this stuff together before I try to, well, for one thing, it's not like terms, but even if it looked like it was like terms now, I can't jump to that until I put these together. So this becomes 49x to the 12th, y to the 4th, which is handy because that actually is the same variables and same exponents. So now 81, take away 49, 32, I believe. And then again, that's a subtraction step, just combining like terms. Don't change the exponents on that step. And so everything on page 4, those are going to be examples that will be very similar to the homework page, page 6. Okay, so on homework 2 for this unit, page 6, those are going to be very similar. And then on the back side, it's going to be easy for us to tell that now we're looking at geometry things. And some of these say find the area and perimeter, or perimeter and area. I think the bottom two only say area. So perimeter, reminder, perimeter is around the figure, going around. And that a rectangle, even though it's not written here, it's like there's another 12x and another 5x squared, because the length, the top and the bottom are the same and the two sides are the same. It's like a rule for that shape. So we kind of have to make that assumption whether we write it or we don't. And then perimeter, we're just adding. So perimeter, you might write by perimeter, combine like terms. Area is product rule. We have to multiply to do area, because area, like for a rectangle, is length times width. So here, 5x squared and 5x squared, 10x squared, 12 and 12, 24x. And that's it. That's the perimeter. Each of these should have two answers because it says find the perimeter and the area. For the area, remember that a rectangle is length times width. So area here, we're doing 12x times 5x squared. So that we're using product rule. 12 times 5 is 60. 1 plus 2 is 60x to the third. The 3 is very easy to read. So this is my area. This is my perimeter. So I'm going to have two final answers. Triangle, perimeter, add up all the way around. So we are trying to add 4a squared b plus 10a squared b plus 3ab. Now, one of these things is not like the other. One of these things doesn't belong. Nobody used to watch Sesame Street. I'm so sad. So a squared b, and then the 3ab would stay by itself. Still part of the answer, still part of the perimeter, but it can't combine with the other two because it don't have a second power. And then area for a triangle is half the base times the height. So base and height meet at the right angle. So we do not use this for area. We're going to do half. And it doesn't matter which one I call the base and the height. I don't really like to do half of 3, so I'm going to, in my mind, think of doing half of 4 anyway. Half of 4 is 2. 2 times 3 makes that 6. And then it's multiplying, so add your exponents, a to the third and b to the second. Or you could multiply the two things together and then divide it by 2. But it's only the number that's getting divided by 2, not the exponents. for 18, that triangle is an equilateral triangle, which means all of the sides are the same. And that means that that inside part is the height. We do not use that inside dotted line for perimeter. We only use it to help us find the area. So if the triangle is equilateral, which it tells us it is, and I want the perimeter, then I would just have 3 of those things that are the same. So I could just say 3 times this. Or I could write 20m to the third n to the fifth plus 20m. I could just write it 3 times, adding. But I should just get 60m to the third n to the fifth. Notice my exponents don't change for perimeter. Area, we're going to take half times the base of the triangle times the height of the triangle. So that's where the dotted line comes in. That's the height of the triangle. We didn't have a dotted line in the last triangle because since it was a right triangle, one of the sides was the height. So here I could go ahead and think half of 20 is 10, and then 10 times 4 is 40, and this is multiplying, so I'm going to add my exponents. So 3 plus 1, 4, 5 plus 5, and to the 10th. And then we have 2 more here. Anyone remember what this shape is? Number 19, what kind of shape is that? That is, well, it's a quadrilateral, but it's a special quadrilateral. It is a trapezoid. It's like one of my favorite math words just because it's fun to say, trapezoid. This is a trapezoid. And the area of a trapezoid is a little more complicated. It's kind of like that whole half the base times the height, except the base at the top and the bottom are not the same. So we use a half because we're going to average those bases, kind of because like if you thought of it like a rectangle, the length's not the same. And so what we do is we add that bottom and top together because we're basically averaging them. Except I shouldn't have written my h over here yet. I don't need an h. I'll be writing 2xy there. So this times the dotted line, because that's the height. So it's like half of base 1 plus base 2 times the height. By the way, the half, you could just do everything and then divide by 2 at the end. When I add these two together, it's 11x squared y. I still have my half. I also have this times 2xy. Guys, I don't want to deal with half of 11. So we can think of, instead, take half of the 2. What is half of 2? Just 1, right? So these two basically just become a 1. They basically, half of 2, we're just back to where we were. So it's just 11, and then x, 2 plus 1 is 3, y, 1 plus 1 is 2. One final example. The circle. The circle. And only area for this circle? Only area for the circle Does anyone remember the formula for the area of a circle?
Radius times.
Ah, there's a pi squared in there. Well, there's not a pi squared, there's a radius squared. So we've got a radius and a pi. So the area of a circle is pi times the radius squared. Where pi is an irrational number, we could use a decimal equivalent, but we're just going to tack pi on it. We're going to just leave pi as part of our answer. And if these last couple are frightening, you won't have something like that on your test. So that gives you a little peace of mind, I hope. So if I want this squared, that's my radius. It's the distance from the center to the edge. If I want it squared, then I have 9x squared y to the 6th, and then we could just put pi at the end. If we use 3.14, we get a decimal. It's approximately, but if we just leave pi, then it's exact. Okay, so that is all your new information for today. You have 2 homework assignments. One is you've already worked on, some of you already finished. That was page 3. And then this one is page 6 and 7. Once you have both of those done, put them into the box, and you are done for today.